Yeah, good morning, good afternoon. Assalamu alaikum. People joining around the world. Thank you for joining our third talk in Tech Talk series, which we have been doing along with CIGI. My name is Abdul Salam Kundumal. My duty here is just to introduce EXL UK. EXL UK is a career wing of a charity group called CAMP UK. And CAMP has been started around 2014 as an organization for Malayali Muslim professionals, and EXL is a subset of that. So basically, we have been doing a lot of work in the career wing of to help the people to progress in their career, especially towards the Malayali community. EXL was formed probably around 2017, and we have been doing lots of talks recently on medical as well as on technology talks. And this one is specifically for all the technology, and we had some fantastic talks in the past. There was last time it was by Siad Kandampilakil, and he was talking about the big data, and there was another one about artificial intelligence before that, which was done by me, and there was quite a few talks by medical professionals, and we have been quite good at. And I think that the encouragement we got was fantastic. And in this one, there is another topic which is again pretty hot recently because there was lots of controversies around it. It's about 5G, and we have a fantastic speaker today, Thenveer Manzil, who has been working in this industry for about 15 years. So you will be on for a cracker today, inshallah. So without further ado, I'm inviting Nizam P to introduce CIGI. Thank you very much, and hope you'll enjoy the program today.
Okay. Good afternoon, everyone, and good morning. From, as he said, from different parts of world, joined together to learn a new technology. We are very much happy and excited to have the tie-up with EXL UK. As we all know, they are the pool of technocrats, technology experts. CIGI, as most of you are well aware of, Center for Information and Guidance India is an NGO, non-government organization working in Kerala, basically. And we have representative bodies in Middle East and some places out of Kerala. Mainly we are into education and employment guidance, and as well as empowerment programs for the grassroots level. So bringing the technology, especially the cutting edge or the latest technology, into the grassroots level, or the people or the students who are aspirants of gaining new knowledge in artificial intelligence or this 5G technology or something related to computer science or data science, etc. So we have been benefited by the tie-up or network with EXL UK, and CIGI could present best brains or best people in this field to the people in the grassroots level. And we are very much happy to have another session in this series. Today, Mr. Thenveer Manzil is taking the session, and CIGI welcome all the technocrats, all the faculties, and all the participants to this wonderful program. Please make use of each and every moment of this program. After the presentation, there will be question and answer session. Make use of that and benefit from the expert panel who are present in this program. Thank you very much. And from CIGI, we assure more such programs will be coming to you by different experts from EXL UK as well as other possible organizations. Thank you very much. Wish you all the best.
Thank you for the introduction about CIGI and EXL. I will invite and introduce Thenveer Manzil to conduct and to take over the session. Before that, I will just go through who Thenveer is. Thenveer is heading the infrastructure, technology, and data center of 3 UK, which is one of the leading mobile companies in UK. And He has almost worked for 10 years in the company. He is a postgraduate in mobile communication from Leeds and Beckett University, and a BTech Computer Science from Cochin University as well. He played a major role in delivering 4G and 5G technologies. So I'm sure he will be the best person to give a talk on 5G technology, which is one of the hot topic in this time. And apart from his technical side, on professional side, he is a good runner. And unfortunately, because of the COVID situation, he can't run one of the major marathon event this year, which is a Paris Marathon as well. So I would like to welcome Mr. Thenveer Manzil. Please go through.
Hi, Siad. Thank you. Thanks for that. Okay, so I will start the session. So let me just share my screen. Just give me 1 second.
Mujib bhai, can you please unshare it?
Yeah, then we are good to share now.
Okay, thank you. Can you see my screen?
Yes, we can.
Okay, thank you. Thanks, Siad. Thanks for the introduction. Really appreciate it. Good morning, good afternoon, everyone. I hope you're all having a good time. Just before I start this one, I just would like to thank CIGI and EXL UK for this opportunity, and also everyone for taking time to join this this session. What I'm going to be talking about here is I'm going to be talking about 5G, some of the main architectural changes in 5G, some of the use cases, and so on. But before I start talking about 5G, I thought it's actually pertinent we talk about some history on mobile technology. And obviously, most of you may have used it, may be familiar with it. So I just thought I'll just give a brief intro to that one. This session, as Salamka said, it's going to last approximately 45 to 50 minutes. And I think there'll be a Q&A session after that. So the first thing I want to try and do is I want to try and start with showing you some pictures here. And these pictures are of some high historical importance and may not necessarily be directly linked to mobile technology. So this is St. Peter Square in Vatican City, and it's a picture taken in 1978. This is just before the election of John Paul II as the next Pope, and people are waiting to see or witness the historic event. And almost wondering what is the significance of this this particular picture and how is it related to mobile technology. There is no direct relation as such, but except the fact that this is exactly 5 years after the first mobile call was made, and it's exactly 5 years before the formal commercial launch of the first mobile phone. It's right in the middle of when the first mobile phone call was made to when the first commercial mobile phone was launched. This is same place 27 years later in 2005. Another historic event. This time it's to elect the next Pope after the death of John Paul II. And many people consider this time, i.e. 2004, 2005, as the beginning of mobile revolution. And you can see in this picture, there are some people using some lonely mobile phones here and there. right? And if I fast forward to another 8 years, this is Papal Conclave of 2013, right? And this is to elect a new Pope after the resignation of Pope Benedict due to his old age, right? And as you can see, there is a stark difference between the people who were attending there to witness that 8 years ago and the people witnessing here. So pretty much everyone's got a handheld device taking pictures there. And the penetration of mobile technology into our lives has just been amazing, and that too in a very, very short span of time. Right, so this actually just shows you a brief timeline on what's happened over the last 3 decades when it comes to mobile telephony technology. So in 1990, there were around 12 million mobile subscribers worldwide, and at that time there was no data service. In 2015, that number grew to 7.6 billion mobile connection across the world. And they were actually, and the users were transferring 1577 exabytes. So that's actually giga, tera, penta. Sorry, 1577 petabytes. So it's 6 zeros after gigabytes of data in just 1 month. And if you look at that, that's actually equivalent of 425 million hours of streaming HD movies, right? And 5 years after, the number of people connected or number of devices connected to a mobile network increased to 8.8 billion. That also includes not just handheld devices, but also includes machine to machine. So nowadays, car comes with a pre-installed SIM card, or some rural places where you've got camera, which has got SIM card installed to that. And it's expected that in 2023, the number of devices that's connected to the world mobile network would go up to 13.1 billion, which is almost as double as the world population as it stands. Right, so for every one person in the world, there's going to be at least 2 devices that's connected. And most of this growth is expected mostly in Northern America as well and the Western Europe countries. And out of that 13.1 billion devices, 10% of the device connected is going to be 5G. Okay. So let me just go back on some of the history of how mobile phone/mobile network came into existence. All right. So I'm not sure if you know this person. He is Martin Cooper, and he is the first person to have made a call on a mobile phone. This picture was taken in 1973, and this is when he was making the first call in the network. And at that time, he was working for a company called, well, most of you are aware, Motorola. And at that time, Motorola was comparatively a small player compared to the giants like AT&T, who provides the mobile network and the telephone network to US, or most of the US. And they're the ones, the AT&T are the ones who actually introduced the concept of mobile technology to the world, and they used predominantly for car phones, so to provide connectivity for people who are traveling on the go. And Martin recognized that this was a very, very narrow vision, and he thought future actually lay in fully portable device, and his mantra was anytime, anywhere telephony. And he put up a small team together to build the first mobile phone, and he started that work in 1972, and by end of 1973 he had a near working prototype. And what he actually did was, when he got the near working prototype, he made a call a press conference and made this first phone call in front of the press. And he actually called head of AT&T, because they are their main competitor at that time. And people often call this as one of the epic troll of all time, where Marty phoned up Joel and said, "Hey, this is Joel. I'm calling from a cell phone which you have not been able to make yet." However, then it actually took 10 years for Martin and his team to translate a near complete prototype into a fully functional mobile phone. And mostly due to some of the technical challenges as well as the regulatory hurdles that he faced during that time. And then he introduced the first mobile phone in 1983, and that mobile phone was often called as the brick because it looked like a brick, and it weighed one kilo, and it cost a huge $4,000 per piece. But still, people thought it was a luxury at that time and queued up to buy that. While Motorola was trying to build the first mobile phone in Europe, Nokia, it was then called Mobira. They built their first the first mobile phone in 1982, and this is a shot from the popular movie Lethal Weapon, and you can see Danny Glover holding the Mobira Senator. Right, it actually weighed 9.8 kilos, and it actually looked like more like a radio or a household telephone rather than a mobile phone. And it actually had a strap so that you can actually carry this device around. And then subsequently, more and more thing came, and now you've got the latest and the greatest phones, such as in the form of Samsungs and iPhones. Now let me just talk briefly about some of the key mobile network technology and how we actually got to where we are today. So obviously the first mobile telephony was first generation telephony. It was introduced in Tokyo in 1979 by NTT, a company called NTT. And in 1981 by in Europe, mainly in Scandinavian country, by a company called Nordic Mobile Telephone, and in 1983 in America by AT&T. And this technology only allowed you to make voice calls. There was no text, no data, latency was really bad. There was no security, and anybody could actually listen into the call at that time. And everything was based on analog signals, and as a result, there were a lot of loads and lot of interference, and the voice were crackling. People couldn't hear properly. 10 years later, in 1990, in 1991 to be precise, the first 2G network technology was deployed in Finland. And this was the first attempt to try and standardize the mobile network technology across the globe. But obviously, it was early days, and it wasn't a success. With this technology, for the first time, people could actually send text messages, could send MMS, i.e. picture messages, multimedia messages. And with this technology, they moved away from analog signaling to digital signaling, which has actually greatly improved the voice calls. There were less static, there were less background crackling, and people started experiencing better sound quality. Because of the attempt to standardize, people could actually roam from one network to another network, which was not possible with the previous technology. And one of the major concern, which was the encryption, was also addressed. So and the technology allowed or supported encrypting the voice calls so that man in the middle could not see what's really happening. 10 years later, then came the 3G technology, launched in 2000, 2001, and it actually supported high-speed internet. It supported multimedia applications such as video calling, video conferencing. People could actually really, well, I don't know if you've seen, but at that time there used to be something called a Skype phone, where you could actually use Skype to make voice calls. And it actually offered a better data rate as well. So it started off with offering 2 megabits per second, and then it actually went on to deliver close to 20 megabits per second speed. And 3G is considered to be, is the one that introduced the concept of mobile broadband, where people could actually buy a dongle and use that dongle to connect directly to the internet. Okay. And then in 2000, again, in one of the Scandinavian country, in Norway, they launched the first 4G network in 2009, and it was called long-term evolution, LTE. You may have come across that terminology, and it actually introduced higher throughput to the world, and made a world realize that people could actually see high quality video streaming on your handheld devices. Nowadays, in certain conditions, 4G technology can actually offer really close to 1 gigabits per second of throughput in certain lab scenarios. This technology facilitated gaming, HD videos, and one of the other thing was it became all IP network. So in previous generation, you had something called a circuit switched technology, whereby that's what was used for carrying voice. In 4G, everything moved over to IP, so the voice is actually carried over data or IP packets, and this is actually a big shift from the previous technology. Obviously, with the improvements in technology, latency has reduced significantly. So latency is, if I want to explain latency, it's basically the time it actually takes for a packet to go from one place to another place. Yeah, and the return latency is time it takes for one packet to go from one place to another place and come back with a response. So in 4G technology, that latency is can be as good as 100 milliseconds around time, 50 to go there and 50 to come back. And as I said, it actually often allowed the throughput to go up to 1 gig, but from an average user perspective, it's more like 10 to 20 megabits per second. Just to summarize, mobile technology has made a leap every 10 years, and the next leap is expected with the 5G technology this decade. And for the rest of the session, I'll focus on 5G technology and how it actually enables world for a better future. Right, so if I start on the 5G architecture, this is the constituent components of a mobile network, and each of these elements have their own designated role to play. And if I start from the left, you have got customer at the left, and with their handheld device, they connect to radio frequency, as in spectrum. And your phone connects to these radio waves on your phones, and that then gives you connection to the radio access network, right? And that's where all the different antennas and masts and everything are connected, and that's the one which actually provide coverage for your network or for your mobile phones. This radio network is connected with a backhaul network back into the core network here. And this core network is often considered as the brain of any mobile network. I'll go into the details of one by one in the next few slides, and then you have all the IT system which provisions all the customers, bills the customers, allows customers to subscribe to various services, etc., etc. So this actually shows the end-to-end picture from a mobile network perspective at a very, very high level. Okay. So let's look a bit more into what spectrum means. So in simple terms, radio spectrum is used to carry information wirelessly for a vast number of vital services, right? So it ranges from TV to mobile phones, to microwaves, radio, etc., etc. And this radio spectrum allocation is actually overseen by a division of a UN, and it's called International Telecommunication Union. And especially everyone probably would have heard about spectrum in a different context, especially the 2G spectrum scam. And this was basically trying to allocate a spectrum for mobile companies to provide their mobile services to the subscribers. So often the spectrum is considered to be a national asset, and it's used by many countries to make revenue. Also, this is used for advancing communication and lifting people up into the modern era. Just going back to the ITU, which is the division of the Mobile Telecommunication or International Telecommunication Union of UN. They meet every 4 years, and they're the ones who actually say, yeah, these are the spectrum that can be used for different purposes. All right. For example, if you look on the radio, many of you would have seen the radio spectrum to say, 98.7. You can see Radio Mango as an example. So that actually is been allocated specifically for radio FM service. So and within that, you would actually chunk up portions of spectrum to different providers so that everyone can actually provide their service to their customers. And it's really important that there are no overlaps, and if there are overlaps, it causes interference and people won't actually be able to get the service. This actually applies also in the mobile field as well. So you've got a vast mobile spectrum, and every operator has been given a specific spectrum for them to use, and they need to use the spectrum only in the allocated space. And they pay a significant amount of money for the government to actually use that spectrum, initially to buy that spectrum, as well as a subscription to hold that spectrum every year. Now let's look at how does the mobile spectrum look like. So just to give you some examples. So from left to right, it starts from lower spectrum, lower frequency spectrum to higher frequency spectrum. So the thing is, with the lower frequency spectrum, you get better coverage, but it can only hold less capacity. Whereas on the right-hand side, you have got a higher frequency spectrum, which allows you to provide more capacity, but the range is limited. So what it actually means is, if somebody's got some spectrum in this space, they will be able to offer a coverage to large space, but the capacity is going to be limited. And on the right-hand side, you would get a lot more higher capacity, but the coverage, the mobile network coverage will be limited. So one of the main challenge with 5G is, how do you make sure that you get the best possible speed, and also at the same time your coverage is actually diminished, and that's one of the key aspects when they actually looked at 5G spectrum, and that's why they've actually allocated spectrum at various different frequencies levels. So 700 megahertz frequency spectrum, that actually provides a lot higher coverage compared to 24 gigahertz spectrum, which is really fast in terms of data throughput. But when it comes to coverage, it's a very small amount of coverage. And what operators are going to be using is they're going to be using all these frequency spectrum to make sure that their coverage and capacities are managed effectively. And when it comes, and I'll actually show in the next slides or so how they're actually doing that as well. Okay. And when it comes to the spectrum allocation, these are the different spectrum. So if I just go back one slide, so this is basically all this one, which is less than 6 is sub-6 spectrum allocation, and the one above 6 is more than sub-6 spectrum. And the next slide just gives you an overview of where people have actually allocated different spectrum across the world. And as you can see, there are still a lot of places where they still haven't allocated spectrum, and India is one such place. Okay. Now I will talk about the RAN network, which is, once you've got the airwaves, how do you then enable that to connect to your mobile phone? And how does that, how is that different from 5G compared to other previous technology? So in the previous technology, I think before I actually go into previous technology, I think it's probably worth explaining what 4T4R actually means. So every radio network or every mast has got more than one antenna sitting on it. And similarly, each device may have one or more antenna on it. In a standard setup, what you would have is you would have one antenna on one antenna within the radio side, as well as one antenna on the mobile device side. And you can only transmit and receive once. So when you're just transmitting something, you can only transmit, and when you receive, you can only receive, right? So basically the usage of spectrum is not very efficient. And as part of improving the spectrum efficiency as part of 3G and 4G, they've used a concept of 4T4R, which basically means that a device will have 4 transmitting and 4 receiving antenna. And similarly, the radio, the mast also have 4 transmitting and 4 receiving. What it actually means is, as you can see here, they can concurrently transmit and receive data across multiple antennas. I think iPhone X and iPhone XS offer 4T4R, and that's how they theoretically can actually achieve a speed of close to 1 gigabits per second. The previous generation 3G, it only allowed 1T, 1R at a time. And what 5G is actually going to offer is the concept of massive MIMO. So it's effectively 64T, 64R. Yeah, and that with a combination of something called beam forming, we can actually achieve high throughput rate, right? And the table below shows a comparison when it comes to coverage and capacity. Yeah, so if you remember, most of the countries are using 3.4 and 3.6 gigahertz. And effectively, from a coverage perspective, the way they're actually achieving a coverage which actually can be provided by a 1.8 gigahertz spectrum in a 4G technology is by using this 64T, 64R beamforming technology. And from a capacity perspective, what this is based on some real test data, is it can actually enhance the capacity by up to 5 times based on some early indications and early spectrum usage. And this is how it actually achieved that level of speed, capacity, as well as the reliability. So one of the technology that's been introduced, or antenna technology has been introduced as part of 5G, is something called spatial multiplexing. So it basically means that same data is actually sent over multiple paths, so that the device don't lose coverage, or they actually have got high availability when it comes to the network. The next technology is, I think I've briefly mentioned, is 3D beamforming. So basically, the concept is very simple, similar to how you do. So the concept of flashlights and laser point light. So if you go to your room and turn on a spotlight, the light spreads, but it's actually limited to a specific area within that room. But if you've got, let's say, something like a focused laser beam, you can actually get to much further distance. And that's exactly is the technology that they're actually doing. They actually send the radio signals in a specific direction so that it can actually travel further distance. And the third technology is what they called multi-user MIMO. So this is basically sending data using a single transmit for multiple customers simultaneously. So the simple way of explaining that one would be you taking a shared public transport, whereby a bus is going in a particular direction, people hop off at various points based on their requirement or where they need to go. And this is a similar technology that they're actually employing. And with all these different technologies, what 5G is offering is much efficient spectrum. Sorry, much efficient spectral utilization. Okay, and just from a physical perspective, I think in old days where we had one antenna that was going to do 2, 3, and 4G, in a 5G world, need to have a much bigger antennas and much more antennas to provide the same type of work, and as a result, I think the antennas and the tower on which you're going to put the antennas is going to need to be a lot more stronger compared to the other ones. I think we spoke about speed in one of my previous slides, and this is when it comes to the capacity. So what is actually showing is, again, some test results. So in a single area with the 4G technology, in a single sector within a 3G technology, if it can actually achieve 30 megabits per second, you can actually theoretically achieve, not theoretically, you can achieve 840 megabits per second throughput in a single sector using 5G spectrum. I think it needs to be at least 100 megahertz with massive MIMO technology. Okay. And the next one I'm going to talk about is black. I will move on to core. And so I think I've mentioned previously, core network is considered to be brain of the mobile network. And it is where voice and data is routed across various subnetwork to ensure that it actually gets delivered. So for example, if somebody want to make a call from here to here, it actually needs to go to the core network first to understand how it needs to route to here. And all that intelligent part is run in the core network. So typical things it actually does is it actually authenticate users to the network. So i.e. only users who are allowed to access the network can get access to the network. It makes sure that the traffic is sent to the right base stations. It's the one that facilitates call forwarding or forwarding to the voicemail. That's the one which actually controls the messaging, right? And also, if you want to connect to the internet to serve or to access content from Google or whichever, YouTube, core network routes your traffic to the right content providers to get the content. And lastly, it's also the one who actually looks at how much data you've used so that customers can be billed correctly. Okay. One of the so with every change in mobile technology from 1G to 2G to 3G to 4G, along with changes happening in the radio side, there's also big changes that usually happen in the core network as well. But in the instance of 5G, what standards body, specifically in this case GSMA, have decided to do is rather than waiting for everything to go into full 5G, they've divided into multiple phases or 2 phases mainly. And the first one is called non-standalone deployment. And in non-standalone deployment, the way they're going to be doing is you will have a 4G radio network and a 5G radio network, but you only have a 4G core network. So 4G core network will provide services to the 5G customers using 5G radio network. Whereas in standalone mode, which is basically you actually upgrade your 4G core network to 5G core network, and the 5G core network is based on standard defined by ETSI, NFV, and SDN. I'll come to that one in a minute, but in simple terms, network function with virtualization and software-defined network. And I think I've briefly mentioned that in 4G, the voice is carried over data network, and it's actually called voice over LTE. And in 5G, it's called voice over new radio. So if you hear a 5G new radio, which basically means that's a radio technology used for 5G. And what we're saying is, with introduction of standalone, we'll move to these NFV, SDN, and voice over new radio technology, and we'll fall back to VoLTE, where they do now have coverage for 5G network.
Namsit, you have 15 more minutes.
Thank you. Yeah, I'll try and fasten up a bit.
Thank you.
So just a quick overview on the virtualization. So I think many of you, if you're in the IT industry, know about virtualization. So traditionally, what you had was one server running one application. So if you need multiple application, you needed multiple hardware. What 5G technology is driving is a standard whereby you have a common hardware platform, you have virtualization on top, and you have different virtual application running on top. And one of the key reasons for this one is to optimize the cost operators have to bear when it comes to 5G, because 5G is going to drive massive throughput, and you need to make sure that it can be the data services for the customers can be provided at the same rate as we provided for 4G, but provide similar amount of traffic as well. And this is a standard that's actually been defined by, as I mentioned, ETSI. It's a standards organization, and they define how this should be defined if you need to have a virtual application running on a telco network. And this makes sure that some of the availability requirements in 5G, in 4G and below, some of the availability requirement from our regulators are it needs to be 5 nines available, which basically means that in a year you can have up to 8.5 hours downtime. But when it comes to 5G, some of the requirement from the 5G standardization body is that it needs to be at least 7/9 available, which basically means that you can only have services, end-to-end service go down for less than 5 minutes in a year. Another capability that's going to be introduced as part of 5G is something called network slicing. So it's basically virtually splitting up the network for different use cases. So you'll have a network slice to provide the normal network for your mobile subscribers. You may have a different slice for example, truck manufacturers, fleet assistants. They have a different availability and latency requirement compared to a standard mobile handset subscriber. And similarly, machine to machine, GPS, those things may have a separate requirement. So what 5G allows you is to virtually segment the network into different slices using the same hardware here, or different hardware depending upon the requirement, to provide requirements to different subscriber needs. So that's a main architectural view on the 5G, and I'll just quickly cover 5G use cases before we go into the Q&A. So this slide actually shows some of the main, the main use cases for 5G is actually defined in a triangle. So there are 3 main use cases. First one is extreme mobile broadband. Second one is massive machine communication, and third one is critical machine communication. Okay, and the extreme mobile broadband actually offers peak throughput rate of 10 gigabits per second, and the requirement is on an average each subscriber get 100 to 200 megabits per second possible, and also in a specific area they get 10,000 more capacity. The massive machine communication, this is mainly for introducing more and more machine-to-machine devices to the network. So a small example would be your meter, your utility meter in future may come with a SIM pre-installed in it. But one of the requirements is that it actually lasts for 10 years of battery. It doesn't actually demand as much battery when it comes to radio compared to the handsets or the other things. And the other one is critical machine communication, which is basically something which requires ultra reliability, as I said, 7 nines availability, or something which requires very, very low latency, for example, automated cars. And these and all the use cases in 5G are based on this triangle model here, and these are the requirements as set by IMT 2020 as a requirement for 5G. Now, talking more about those ones. So if you look on enhanced mobile broadband experience, the key requirements are you need to have extreme high throughput, low latency, and uniform experience, right? So I think just to give you a quick example, to provide extreme throughput, if you're doing virtual reality or augmented reality for gaming services, that's a use case where you would need extreme throughput with ultra low latency. Another one is, I think most of you probably would often, if you go to a football stadium where you've got 100,000 people crammed into a small space, you often struggle to get a decent data speed. That's one of the things 5G is trying to resolve with enhanced mobile broadband. Okay, so what I'll do is I'll actually quickly show a quick video which talks about what 5G can actually offer when it comes to extreme enhanced mobile broadband.
"5G will be revolutionary, not only in urban areas, but also in rural America." My name is Ana Tavares Latibodier, head of the North America region at the GSMA. The GSMA represents the interests of over 750 operators worldwide. 5G network access will enable doctors to virtually operate on patients that may be thousands of miles away. Through robotic surgery, patients will have access to a level of healthcare quality that they've had to drive hundreds of miles for in the past. The elderly and the chronically sick will be able to use mobile-enabled wearables and IoT devices to provide real-time health and home care monitoring. To students in remote areas of the country, 5G represents an amazing advancement in the accessibility of data and tools for learning. This is made possible through augmented or virtual reality, which are even more capable when they're connected to a robust 5G network. Imagine an elementary school class in Mississippi taking a field trip to the Taj Mahal, or a technical school actually being able to see what it is like for highline crews to maintain transmission lines within the electrical grid. 5G will have a significant impact on folks in agriculture as well. Mobile IoT will result in increased crop yield and quality, as well as more efficient and effective livestock management. Through enhanced monitoring of soil and weather conditions, farmers will be able to refine their use of pesticides and fertilizers and improve how they care for their animals. Remotely operated drones and farm equipment could even be used for crop spraying, land management, and surveillance, all enabled by the increased bandwidth and low latency that comes with 5G network connectivity. Innovators in every corner of the country should have access to this technology, including and especially those in rural areas.
The next use case is massive Internet of Things. So I think just to call out one or two examples here, remote access or remote sensors actually. So where you've got farmlands, which is quite remote, and you want to understand what's happening there. This is where one of the example where you can actually put a 5G device with very with the requirement, which is it's going to have 10 years of battery life. You can just put it there, and it can just continuously monitor and send information to you on a regular basis. Another one is object tracking. So if you are sending some shipment in a containers, you could actually put trackers to make sure that where they are and how they are doing, especially when they've got certain requirements, such as it needs to be kept under certain temperatures. So let's look at another example, which is another use case for this one is how 5G is actually going to benefit smart cities, especially with these devices. Which is one of the key things with the smart cities is sensors all around the place. So this is an example from Los Angeles, America.
We live in a highly connected world. As CIO for the city of Los Angeles, I oversee the information assets of a city with over 4 million residents, 500,000 businesses, and 48 million visitors every year. For them and for us, 5G is really a game changer. We see tremendous digital opportunities with 5G, allowing us to empower, engage, and protect those who live and work in and visit LA. 5G will enable an ultra-high-speed network that connects all of our things together. With the massive connectivity made possible by 5G, low-cost thermal sensors will tell 911 about a fire early, before it threatens life and property. With ubiquitous coverage, real-time evacuation notifications can be sent anytime, anywhere. 5G delivers data with very low latency, which means information travels across the network faster, allowing critical decisions to be made quicker. Under the leadership of Mayor Eric Garcetti, Los Angeles is launching its earthquake early warning system. As one can imagine, every second counts when you're notifying schools, hospitals, factories, and residents that an earthquake is only 20 to 30 seconds away. 5G enables cloud infrastructure and edge computing. This means a superhuman knowledge base with machine-to-machine interactions for proactive government services, crime prevention, trash collection, and even smart parking. In a city as complex and diverse as Los Angeles, this enables us to improve life for all of our communities. Much like the early days of the internet or the smartphone, the greatest uses of 5G are probably yet to be imagined. We are on the verge of a new era in wireless connectivity. Emerging technologies are both the issues and the opportunities of our lifetime. And Angelinos are counting on us to get it right in Los Angeles.
Yeah, and moving on to the last set of use cases. So this is for mission critical control systems. So a good example is, how do you remotely do surgery? Or how do you remotely drive a car? So I think I've got a couple of examples here, and then we'll.
With the arrival of 5G networks, higher bandwidth and lower latency will directly contribute to better diagnosis and faster triage. That will save lives. My name is Rafael Grossman, and I'm a surgeon, a teacher, and a healthcare futurist. Today, there aren't enough healthcare resources to meet the world's needs. We know that about 2/3 of the world's population, about 5 billion people, don't really have access to safe surgery or to affordable surgery. We need to really use the technology that we have at hand, like 5G, to shorten that gap between what we can offer and what we need to offer. The clarity of high-definition video in 5G will make telehealth experiences more comfortable and accurate for rural and remote patients. As a surgeon, the more I can see, the better my diagnosis. 5G connected wearables will facilitate streaming of real-time data. They can monitor how much you are active, or your heart rate, or even your blood pressure with the touch of a button. The use of virtual and augmented reality will be invaluable for providing lifelike experiences when teaching medical procedures. Healthcare is about communicating and connecting better. Having no perceptible latency will allow us to have a real-life conversation, but at a distance. We know that 80% of people with healthcare questions don't need the physical contact with a provider in order to be successfully advised or treated. Remote surgery using semi-autonomous robots will be feasible. So will the use of AI and deep learning to analyze CT scans, MRIs, X-rays, and other imaging studies to vastly improve our medical diagnosis. I think 5G is going to cause a paradigm shift in healthcare. Everything from prevention to treatment to rehabilitation, teaching, and mentoring will be enriched. 5G will elevate the quality of care throughout the US and around the world.
Right, so just to summarize then, what's actually 5G bringing with regard to compared to the previous predecessors. So 5G reduces the latency by 10 times. So 4G, you had latency of 50 to 100 milliseconds. Now we're talking about 1 to 10 milliseconds. It increases the connection density by 10 times. It brings a spectrum efficiency by 3 times. So if from an operator's perspective, you can actually serve customer demands 3 times with the same spectrum that they have got. Massively improved throughput experience and massively improved networks efficiency. So let's look at where we are currently when it comes to what we intended to do and where we are with the current 5G deployment. So from a throughput perspective, vision was 20 gigabits per second. With 4G, as you can see, the peak most of the operators can do at the moment is 150 megabits per second, but an average user is getting approximately 20 megabits per second. But with the current 5G deployment, they can get a peak throughput of 1.5 gigabits per second and average throughput of 200 megabits per second. When it comes to latency, the requirement was to have 4 to 1 milliseconds to enable, well, one of the main requirements is to enable automated cars. So where we are at 10 milliseconds with the current 5G deployment. And when we actually go to the next phase 2 of the 5G, which is the standalone deployment, which we're expecting the latency to come down even further. And with that, I think I'm just going to, oh yeah, so this is just a quick roadmap. So I think I've already said it's a non-standard alone deployment at the moment. Most of the operators are deploying 5G used on 3.4 and 3.6 megahertz spectrum. There is a standalone deployment that's coming further down the year. It's going to be standardized in 2020 for mass deployment in 2021 and 2022. That's going to further enhance 5G capability, and there's going to be more improvement made on 5G in 2021 and beyond. And with that, I'm going to stop with the slide, which is from a carrier opportunities perspective. So a telecom network end-to-end need to have a lot of different skill sets, starting from radio engineering, construction engineering, infrastructure engineering, security. There is a lot of different skill sets required for different operators across the board, and 5G instance, especially at this initial stage, is going to provide a lot of opportunity for different people in there, and it's expected that over the next 5 to 10 years, the industry is going to spend $1 trillion in expanding 5G network. So with that, I will stop and I'll pass on to Salam Siatka.
Okay, thank you very much, Thenveer. It was completely packed, I think, with a lot of information. And now the next session is a question and answer session, which will be led by Siad and Mujib. And there are loads of questions we have got over the chat window you might have seen. I don't think we'll have time to take all of them, but we'll try to answer as much as possible. So Siad and Mujib, over to you guys.
Yeah, Thenveer, it was an excellent session. You put a very good ground and basic information about the 5G, and then touched upon the applications and carrier and future. It was broadly covered all aspects of the 5G technology. It was an excellent session. I hope everyone has made use of the session. So as Salam said, we are going next to the question answer. And in the question answer session, we will have Thenveer as well as Nemshid leading it. So Nemshid is a telecommunication test specialist. He had around 12 years in the industry. He had been working with various telecommunication giants in testing. He also have his own startup in consulting test around the Europe. So I welcome Nemshid also in this session of question answer. There are two questions I just start with, one to Thenveer and one to Nemshid. Thenveer, the question to you is, how is the 5G rollout plan in India in the near future? And to Nemshid, you can take up from a testing point of view, how does the E2E testing work works for a 5G rollout? So I hand over to both of you. First, Thenveer, you go, and then Nemshid.
Sure. So in India, India's yet to do the spectrum auction for 5G. So initially it was planned for April. I think that is now moved out. So I think it's going to happen possibly towards the end of the year. And once the spectrum is announced, we think it's going to take probably around 1 to 2 years to launch 5G. So probably would expect around end of 2022 to launch 5G in India. And once it's actually launched, as you saw, you've got to go and replace the radio across India. And that's going to take a number of years. So if you compare that with UK, in UK we do some like 5,000 site replacement in a year. So and India's got UK's got 25,000. It's going to take 5 years. But in India, you're talking about more than 100,000 sites across India. So depending upon how fast, but once it starts, it's going to be 2027 by the time they roll out 5G across India. Does that answer the question?
Yes, thank you, Thenveer.
Nemshid, you can answer the second question.
Yeah, sure.
Yes.
I hope you can hear me loud and clear.
Yes, we can.
Okay. So, hi everyone. Assalamu alaikum. So prior to the rollout of a 5G network, it has to be well tested and signed off by the relevant telecom regulatory body, Ofcom in the case of UK, I believe it is TRI in India, and various other government organizations. So testing plays a very important role to ensure 5G solution is fit for purpose from a functional performance and security point of view. So from a testing purposes, companies use a lab to simulate the various elements of 5G network. There are usually dedicated testing teams in a telecom setup to run the various functional security performance testing before it gets anywhere close to the rollout phase. And in order to do this, there are various products available in the market that provides the various level of simulation that are required in order to run these tests. And you can simulate various bits of that 5G ecosystem, from simulating the 5G devices called UEs, the base stations, the G-Node Bs and the E-Node Bs, and the 5G core services. So if you recall from the earlier slide from Thenveer, in the telecom ecosystem, there was a slide that mentioned the core. So I'm going to dig a bit deeper into that. It'll not take much time, but just to show a breakup of what are those core services that typically gets tested as part of the 5G rollout. Not sure if we can bring up that slide though that shows the breakup of that. So yeah, could you bring up that slide, please?
Yes. Mujib bhai, can you please take it to that? Hello.
Yeah. So what you see here, are the various elements that form part of the of the core infrastructure. So on the left hand side, what I've shown here is the test setup of a typical 5G code testing. That shows the what are the elements of a 5G network that are typically simulated. So if you walk into a lab, you will see these are various radio equipments that can generate radio frequencies to simulate a 5G network or a RAN. And on the right hand side, what you see are the typical scenarios. So you have various call flows like LTE attach, SMS, VoLTE calls. And for each of these scenarios, it would flow through the various elements of that core network, like EPC, GLAN, IMS, messaging, SDM security, and NetAct. And all this would be part of the cloud band and the transport layer. Now, it would be beyond the scope of this discussion to go into the details of how these components work, but maybe I could shed some light on a very high level what each of these sub components of the core network what they perform. So EPC is a packet based mobile core running both voice and data on 4G and LTE network. GLAN, it's a network where the service providers typically provide value-added services through a combination of IP-based service functions like firewall, CIGI NAT, deep packet inspection, policy control, traffic and content optimization. IMS is a huge area in itself, but typically it is an architectural framework for delivering IP multimedia services. SDM / SDL, it's a user data convergence standard. It's based on the 3GPP compliance to centralize the user data into single secure UDR, or just user data repository. Security aspect of it, this is to safeguard the network against various threats, against any potential attacks. There are many products out there in the market. One of them is the product from Nokia, which is a Nokia NetGuard. NetAct, it is a set of tools for managing the network elements in mobile radio and core, including multi-vendor, multi-technology environment for 2G, 3G, 4G, LTE, and 5G. And finally, the cloud band. This is to orchestrate, host, automate, and manage virtualized networks, or VNF, and the various services. So in a nutshell, these are the breakup of what those core services are and how you would run the LTE attach, the SMS, and the VoLTE calls that would trigger the functionality within each of these services. Again, this is a broad area in itself. Typically, you have thousands and thousands of test cases across these various areas in order to run the end-to-end test successfully. And yes, that's the what a typical 5G end-to-end testing looks like. Thank you.
Thank you, Namshit. It was very explanatory from your side. Thenveer, it was a very good session. I was intrigued to see that how big was the mobile phone, the first ones. I can't even carry on my head. There is a question from Fawaz Rahman. Will there be any relation between 5G and Wi-Fi? Just asking like head net. And one more question from him. How will 5G latency be lower if processing is being done in the cloud? So if you can take up, please.
Yeah, so the first question was is there a relationship between 5G and Wi-Fi? Absolutely not. It's two separate standards. So it actually are two separate standards running in parallel. I think it actually, in effect, is going to complement itself, just like how it actually complements 4G. So yeah, it's two different standards define 5G and Wi-Fi technologies. I think the only thing.
Sorry,
Sorry, yeah. The second question was latency. How does it introduce latency or reduces the latency? So the first thing, the cloud. So when we talk about cloud and virtualization in mobile, we're not talking about using public clouds like Amazon's and Azure's and Google. It's about building clouds within the operator's network so that you can virtualize it. So one of the key principles that 5G is going to follow, which I don't think I have covered in my, is mobile edge computing. So what you're actually doing is you're actually going to be pushing out some of the functions. I think Nim should show some of the functions such as EPC and GI LAN and connection to the internet. You actually push those things out to the edge so that it's closer to the customers. So there are even things such as some operators are actually doing in collaboration with people like Google, where you actually partner with them and you provide some space to Google so that Google can actually host their content within an operator's network. So you'll have their caches sitting in operator's network. So 5G, well, just coming back to the question. So the cloud doesn't necessarily add any latency. The latency improvement is brought a lot in the radio side. And the second thing is by pushing technologies towards the edge and more closer to the customer will improve latency.
Thank you, Thenveer. Another question from Arif. Before going to that question, if any of the participants wants to ask any question directly to the panelists, please raise your hands and we can open up and unmute your audio. So another question to one of you, Namshit or Thenveer. The question is about the financial implications for software or app developers in terms of making app development or software development compatible with the 5G. So all the existing one or most of them are on the previous technologies, isn't it?
Thenveer, do you want to take that one?
Sorry, Siad, can you just repeat the question?
So basically, is there any financial implication for the software developers and app developers when they are when the technology is moving from 4G to 5G?
No, so I think one of the thing that not strictly related to 4G and 5G, but one of the things that a lot more core network software suppliers are providing is APIs, open APIs. Yeah. So from a developer perspective and also from an operator perspective, they've got an opportunity to enhance their services and applications by directly interfacing with the operators' functions. I think just call one out is I think in Namshit slide again there was he spoke about IMS, and one of the component within IMS offers a certain type of value-add service when it comes to the voice. So what operators and what application developers can actually do is call out those functions specifically to provide certain types of applications to or services to the subscribers.
Thank you, Thenveer.
There's some people raising hand. Do you want to unmute their mic to ask?
Yes, you can please unmute. By the time, I'll ask one more question.
One second, I'll ask him. Okay, can you unmute yourself, Wahab? Oh, is he gone?
Okay, can I ask one more question by the time they will come back? This is a question to panelists again. Can you share your view on car automation and 5G technology? I think you have already touched as part of your video and your presentation, but just if you want to reiterate anything on that, please.
Yeah, so I think so there are a couple of specific use cases when it comes to 5G or 5G enabling when it comes to car and automation or autonomous car. The first one is autonomous car by itself don't require 5G, but where it actually becomes useful is in future. What 5G is going to do is 5G is going to autonomous car will have 5G connectivity with which they actually communicate constantly with the roadside sensors and other cars, so that they can actually reduce the accidents. And there have been a number of trials. I think the recent one was one in China, where they actually installed all these sensors and used autonomous cars with 5G deployed in it, and see if they how they can reduce the accident. I think one of the use case they were showing was in corners, right? So autonomous car works a lot on sensors, right? In corners, they don't often see what happens behind the corner. So if you've got sensors on the roadside, which can actually detect a car coming from the other side of the corner, and they can actually communicate that in real time to the other car, you can actually avoid accidents or reduce the propensity for accidents. And some of the studies were actually showing is that in 1 hour with the autonomous car with 5G, the requirement is for a car to transmit and receive up to 1 terabyte of data within an hour, if I'm not mistaken. The other use case is remote driving. So, and this use case is valid where you have to drive in a very risky environments. For example, a mining site where you've got to drive trucks to get things out, and you've got to drive through a narrow road. And obviously, with mining, there is a lot of security or health and safety issues with roadside being very narrow. So what 5G allows you to do is, with the latency as small as 5 to 10 milliseconds, they can actually remotely drive the vehicle without any people in there.
Thank you.
Maybe if I could add another point on top of that,
Sure.
there is an organization called 5G AA. It's called 5G Automotive Association, formed back in 2016. It's a cross-industry collaboration between car manufacturers, technology companies, and telecom companies. And what they aim to do is to make end-to-end solutions for future mobility and transport services. So it's mainly driven by the need to develop more 5G end-to-end solutions going forward. So some of the so we have the technology now, but there are organizations that's working to, okay, now once the 5G is rolled out, how best we can use the ecosystem to develop new solutions. And that's
Thank you, Namshit.
Yeah,
Sorry.
that's a new trending activity on 5G.
There is a lot of question came about a health risk and new controversy about 5G. Then if you can give some light into that, it will be great. Many people ask the same question.
Can I just add one more thing on that one, very related to that? The other question is actually Since 5G employs millimeter and millimeter waves similar to the prototype device from the US military used for crowd control, their active denial system emits millimeter waves as beam that penetrates the very top layer of skin and produces deeply unpleasant heating sensation. So the question is, can the 5G as use as a weapon in the future as well? So the other one is actually asking about the health risk, and this can be used as a weapon in the future. A very excellent questions actually. Panelists, do you want to please take it before we go to the next ones with the participants?
Right, the health question. I think would have been nice to have a health expert on the panel as well. But I think there are a few things. So I think one of the main concern with the 5G is the usage of millimeter wave for providing the service. I think I was showing one slide earlier where which frequency spectrum are actually being used for 5G currently and what's planned for future. So currently, as it stands, the only frequency spectrum allocated for 5G are mostly in the microwave region, so within 1 kilo or 1,000 megahertz to 30,000 megahertz. And millimeter comes well beyond 30 megahertz or 30,000 megahertz rather. When it comes to the weaponizing of that one, I don't know. I really don't know the answer for that one. But when it comes to the health risk, I think there were a few studies from the World Health Organization. I think there was one back in 2016, which basically said there is no proven evidence that it can actually cause a health risk. I think there was another study which came again in 2018, which also said there is no proven evidence. But I think I know there is a lot of debate going on in the industry whether it actually poses health risk or not health risk. At the end of the day, it's radio waves. It's radio waves with higher frequency. If you are exposed to radio waves at a higher frequency for a longer period, maybe, I don't know, but definitely from a regulation perspective, specifically in UK, there are a lot of regulations with regard to how you can actually deploy antennas, and they actually make sure that there is no direct or from a people perspective, they cannot be exposed to a direct radio under a certain distance. So there are a lot of precautions as part of the standardization that happened as well.
Hi guys, I think we are, so far, we probably take 3 more questions and then I think we may have to draw it to a close. So if you could just speed up a bit. I think there is a guy who is raising hands, Sahir. So do you want to ask the question? Next question, Sahir.
Yeah, thank you. Assalamu alaikum all. So the question really is, we've heard a lot about the dependence on China in terms of the vendors who are laying out the technology framework. So with so much riding on 5G, with mobility and Internet of Things and automation, high performance computing, all the things that you've talked about. Is this sort of reliance really a cause for concern, especially with the tensions between the Western democracies, so to speak, and China?
I think this question is mainly on the context of the Huawei scandal, I guess, isn't it?
Yeah, mostly that, but not really sure who the other major competitors are and how they stack up in terms of pricing.
Yeah. Okay, Thenveer, do you want to take the question?
Yeah, I'm happy to. Namshid, chip in when you want to. So Huawei is one of the most advanced provider of telecom equipments. and they are one of the most competitive provider of telecom equipments. And when it comes to UK, I think 3 out of 4 operators are using Huawei radio for 5G. So the news on not using 5G, Huawei for 5G is definitely a setback from an operator's perspective. But it's not that they have to replace them immediately. They've been given a time frame to replace them on a gradual basis. I think the timeline goes all the way up to 23, 24. I don't know. I can't remember on top of my head. So that's point number 1. Point number 2 is when it comes to other providers. So Ericsson and Nokia are other providers who are also not similar, not far behind Huawei. Let me put it that way. In my view, not far behind Huawei when it comes to 5G, and many operators within UK have signed a deal with those telecom equipment providers to provide 5G. So the strategy people are adopting is they'll continue with Huawei for the time being. They're going to put another equipment provider in the form of an Ericsson or in the form of Nokia, and they will replace Huawei. I think the current guidelines at the moment is you can have 35, this is in UK, 35% of your network on Huawei equipment and 65 with other providers. It needs to be other providers. But obviously there are exceptions when it comes to 35. It can be near an army base, it cannot be near critical infrastructure locations, etc., etc. So definitely a setback, and it's going to cost operators a lot of money, but that's Trump for you, I suppose.
Okay, thank you. I think we can probably take one more question, Siad. We don't have time, any more time.
This is one of the questions I have, but I can see another one here coming through, coming from Fauzi Ahmed. The question is actually, we can see a lot of website, blogs, and YouTube channels, many other things in the internet. But what is the best channel or the ones you recommend to track with the telecom industry, technology updates, etc.? That's a question from Fauzi Ahmed. Well, I have another question to add on. If a student or somebody wants to do their career in technology, in telecommunication technology or 5G, what is the course you recommend, or what is the path you recommend for that as well? So very similar questions. You can take it as 2 questions. Thank you.
I think Namshit, you may also have to chip in. So one of the things that I'm thinking of doing is add a slide at the end with some reading material. So there are a lot of resources, as you said, available, but the one which I tend to follow is 3GPP standards. So that's the standardizing body which standardizes the different technology. And similarly, there are other resources available in GSMA, which is also very helpful. The third one I follow is there is something called SDX Central. It's a website. They've got a lot of contents on 5G, NFE, virtualization, and so on and so forth. But I think what we can do is I can put that link at the end of the pack if you're planning to share that.
Yeah, I was going to suggest GSMA website as well. Maybe on top of that, there are lots of white papers that the telecom providers usually publish on their websites. So that's another area that you could potentially get some valuable information as well.
Thank you, Thenveer.
Okay, thank you. I think, sorry, you may have to stop it there, Siad. I know there are more questions coming in. Thank you all for your, there were some excellent questions and discussion points in there. And next, can I invite Rauf to say a few words on word of thanks, and after that we'll close the function. So Rauf.
Yeah, am I audible there? Can you hear me?
Yes.
Right. Okay. Can't see me.
By the way, Rauf is who is the one who is working on putting this on the website and on YouTube channels and everything. He has been working hard behind the scenes for all the talks which we have done in the past. So Rauf, over to you.
Thank you, Salami. Assalamu alaikum warahmatullahi wabarakatuh. May peace be upon us all. Let me first of all start by giving the glory to Almighty for making today's session a very resounding success, if I may, like all other previous sessions that we had on the technical talks and medical talks. Now, my words may not be capable of expressing the sense of obligation that we have for the CIGI group, but I will take this opportunity to thank CIGI, the group led by educationalists, the sociologists, community leaders, teachers, technical experts. So they richly deserves our gratitude, and I offer the same to Mr. Zakaria MV, the director of CIGI Career Division, Dr. Zede Ashraf, the General Secretary of CIGI, Mr. Nisam AP, the Director of CIGI HR Department, Mr. Anas Bichu, Administrator CIGI, and Mr. Tanzil Toha, PRO CIGI. Now, no one can imagine this event like this cannot happen overnight. And the wheels started rolling a few weeks ago, as you can imagine. Now, permit me to express our sincere thanks to EXL UK, Camp Executive Committee, the organizing committee, our panelist group led by Namsheed and Thenveer, the moderator team led by Siad and Mujib, and our technical guru and organizers Salam and Rubas. Now, the end-to-end testing was well explained, Namsheed, and I must also mention our sense of appreciation and to all the other participants and audience here on Zoom and on our YouTube channel. Thanks to you all for your time and patience, and I hope you enjoyed this session and this learning experience. And finally, and yet more importantly, if I may, I would like to thank Thenveer Manzil, who has kindly given his time to enlighten us all on the subject of 5G network or 5G technology. Thank you, Thenveer, for the enlightening session. I found the evolution, the spectrum efficiency, the coverage, capacity growth, ultra low latency. That was very interesting. I mean, personally, it took me back nearly 20 years when I was part of the team involved in the launch of 3G in the UK. That was back in 2001, 2003. It was launched in 2003 in the UK by 3 Mobile. And I'm not that old, by the way. So like I mentioned, Martin Motorola with his first prototype was before I was born. Now I can actually visualize Siad holding on the mobile on his head. Anyway, then we hope to see you again on your other area of expertise on or 6G, inshallah. Until then, let's all enjoy some of the exciting futures 5G will bring us. Thank you.
Okay, thank you very much, Rauf. With that, I think we are concluding that session. Thank you very much, for joining, and you all have a good rest of the day. Thank you very much.